In today's video, we'll be talking about hexagonal architecture in software development. Hello everyone, and welcome back to another video of Serverless DevWidgets. In this video, we're going to continue our journey creating an end-to-end microservice, specifically our events microservice. If you want to catch up on some of our previous videos on this topic, please click the link. Hexagonal architecture is basically a way to organize our code. It's a way to be able to make logical boundaries of what belongs here, what belongs there, and so on and so forth. Hexagonal architecture's main focus is to create loosely coupled components within our microservice. Basically, that you can test, you can modify, you can change component number one with needing none to very little changes on component number two. This has a lot of benefits. For example, being able to do a significant refactor of one component, or being able to change, for example, the database on another component without affecting anybody who's consuming those APIs on that component. So let's draw this out a little bit and let's start calling out different pieces of hexagonal architecture. We have a nice hexagon here already pre-drawn for us because I'm not doing that live on screen. And let's talk about the different parts. The key piece about hexagonal architecture is that you have an app that communicates with other components, whether internal, external, etc., through ports or adapters. In fact, another word for hexagonal architecture is port and adapter architecture, but hexagonal architecture sounds so much nicer. So at the center, you have your app. And so your app also has this concept of a domain. And think of domain as the entities or the information that your application is an expert on and acts on. So in the case of our event microservice, events are the domain of this microservice. The communication, let's say, between our application and outbound applications. For example, in one of our previous videos, we talked about this microservice most likely depending on, let's say, like a location or a venue microservice. So it would have an outbound communication to, let's say, a venue adapter. And you can have n number of adapters to outbound microservices, right? Now, inbound can again be a number of inbound communication. So for example, we have our AWS Lambda invocation, right? Another inbound communication could be just plain old, for example, HTTP REST. A third inbound form of communication could be our testing framework, which does, let's do it in proc or in process communication. So if you notice, if you look at this chart, we have 3 arrows inbound, 1 arrow outbound. Obviously, a hexagon is 6 sides. The key point of hexagonal architecture is that there aren't specifically 6 forms of communication inbound and outbound, or 6 different layers to this microservice. It really is as many as your application needs. So how does communication work between these different components? Like each thing I called out here, think of it as its own standalone component. Each piece of this can be tested in isolation without affecting anyone else, right? And we can, if we're doing testing, well, we're not going to test our in-proc testing, but each of these is a different component that communicates with our application. And we should be able to, for example, other than the testing one, test all our different pieces without having to worry about the other one and just mocking generic APIs. Now, that communication between these different pieces of our hexagonal architecture happens through very generic APIs. And that basically gives us one of the main tenets of hexagonal architecture is this loosely coupled concept, right? That I can, for example, have a very generic API, let's say to my domain layer, right? That says, get me entity 123. Now, and let me put circles here to say that app is its own component, or there may be many different mini components within app, and then domain is its own component. And so the communication between all these different pieces in our hexagonal architecture happen through very generic APIs. So my application component could have a get entity 123 to my domain component. And that domain component knows that, okay, in this context that my application is running, it's connected to DynamoDB. It's going to know itself how to build a request to DynamoDB, get the entity, convert it into a plain old Java object, and hand it back to that application component. And this generic API, this loosely coupled communication between these two components, allows us to be able to do things in addition to, like I mentioned, testing. It allows us to, for example, change out that underlying implementation. So for example, that DynamoDB connection to tomorrow, change it to Aurora Serverless without having to change any of that communication between my application layer and my domain layer. So this really helps with maintainability. It really helps not having changes ripple out to multiple hundreds, etc., classes within your application and just confine it to a small set of classes, which is really powerful if you think about it. So let's talk about the folder structure within our Java application and what that would look like. Let's start with the very obvious, right? We've talked about it many times. We are going to have a folder, a package for application. So the very first one would be application. The second folder will be our domain folder. And basically our domain folder has our repository that connects to the database. It has that communication layer between the database and itself, and then that communication, that generic interface for our application. The next folder we would have is adapter. And in the adapter folder, we would have, for example, we talked about it briefly, our venue adapter. All right, so the next folder that we would have is our API. So those are our inbound requests. And so specifically for our microservice, there's going to be an AWS Lambda inbound connection, and then there's going to be a REST directory. So this is all inbound, this is all outbound from our application, and then the core of our application will be in the application layer, and then the information that we are acting on is all in our domain. Now, there are a couple other like utilities and different things, and that would go into a framework folder, and then you can have, let's say, Spring config, let's say logging, and you name it, right? So if you look at all these folders here that we've created, when you, let's say you have a request from your product manager that says, you know, I need you to go in and change the vendor we're using for our venue information. You can go very quickly, look at the folder and say, okay, that is an outbound communication. That's going to be in my adapter folder. Let me go in there. I'm going to make changes here. And chances are you're not going to change any of the other components, any of the other folders in this structure. One other thing that I want to bring up as we look at this folder is how does information flow? So we talked about our inbound as API, right? What does that request look like? So you might already know AWS Lambda has a very specific invocation request object, right? And in that request body payload that your front-end clients sent. And then that specific request object would then be sent to the application layer through what is called data transfer objects, or DTOs for short. And in that application layer, it's going to take maybe only a few attributes, create another DTO to make a request to, let's say, the domain component. And then that domain component returns a response. And then from that response, the application layer again is going to make another DTO to make a request to that venue adapter to say, give me all the venue information for this specific entity. And as you see, that data transfer object that moves from component to component is very specific to that component. And you want to make sure that you don't bleed information, let's say from your REST component all the way into your domain layer. The domain layer only needs 1 or 2 attributes. Those are the only attributes that it should get in that generic request API. Also, in terms of testability, when you have an inbound, let's say an improc request, right? You can make that request, hit your HTTP REST in process, and then you can mock, for example, the domain layer. So this could be mocked. And you could just, for example, test your application layer, or you could test your HTTP REST layer together with your application layer, mock the domain layer, and create an integration test within the microservice. So hopefully I've taken hexagonal architecture and I've broken up the little pieces, the little nuances of it, and I've made it a little easier for you to understand. If you're still confused, I'm sorry, I tried, but definitely reach out on Twitter, comment down below. I'll do my best to try to understand or break it down even further. I really hope you had a good time. If you want to share this with somebody else, please do subscribe so that you can get notifications on more videos in this series. Most importantly, happy coding.